This tutorial is going to look at our Digitizing Probe. This accessory can be used to replicate both 2D and 3D parts. I will demonstrate using the accessory on a ShopBot. We'll look at the SB3 software, and we'll also look at bringing the scan that we've created with the probe into our CAD Vectric software. When you get your Digitizing Probe, you pull everything out of the box, you see that you have multiple tips. There's different diameters, different lengths, different ends. There's also an easy to follow step-by-step instruction manual. The purpose of this training today is to actually go into a little bit more depth, seeing it actually being used, but you can follow through that tutorial and reference that for any troubleshooting that you have. So what we're going to look at here is attaching this probe to the machine, looking at setting up the different tips, and then plugging it in. Sometimes people mount the probe into the spindle. If that's something you're going to do, make sure you have disconnected your spindle, your VFD. Turn that to the off position and remove the key, just to make sure that there's no way that it's going to start spinning and wreck your probe. As you see, the tips here have a threaded male and female end to connect it to the probe. Some of these probe jobs that you'll get into doing are several hours long, and it would be a bummer if you got halfway through and one of these tips came loose. So there's little holes that are inserted in both the probe and the tip, and just take a paper clip, bend it out, and then what you can do is just stick those in there and give it a little extra twist just to snug it up. You don't have to go crazy over tightening it, but just give it a little extra snug just so it makes sure it's not going to come loose when you start your job. Next we'll look at installing the probe. Just for convenient purposes, sometimes you want to remove the dust foot. Your electrical plug on a desktop goes down in that bottom left corner where your Z0 plate is. On your Buddies or your full-size machine, that clip will be mounted up on your YZ car. The probe comes with its own little bracket to install. Two-sided tape. Got to get those two surfaces lined up. See the instruction manual for a little bit more. I'd even recommend getting a square out and squaring it and getting it perfectly 90 degrees from your table. So you can see that by hitting the probe, it's actually turning a little light on. It's triggering it. Make sure that's doing it. As you're doing this too, also look over at the ShopBot 3 software and make sure input 1 is coming on and off before you continue. Next, we need to get the probe in a starting position. So if we're doing a 2D scan around this guitar body, the first movement the probe is going to want to do when you run the file is move in the positive Y direction. So you can see here I just have it set just to the bottom of this guitar body, and I have the probe itself, the tip, about 1/4 of an inch down, because all I'm going to be doing is going around the profile. So I have the tip about 1/4 inch down off the face of this guitar, and it's just going to run itself around there, and then we're going to pick it up and go into the different pockets and different holes that need to be aligned back up with this actual model. This is just personal preference. Once I hit the probe in the starting position, I like to go into the SB3 software and zero out my X, my Y, and my Z. It's just easier for when I import it into the CAD software. So you can see here I'm at my coordinates, but I'm just going to go up here and go 0, 3 axes, and then have all those go to 0, 0, 0. And again, for me, it's just an easier reference. You'll see in a minute when we bring this into the Vectric software. So from your command console here in SB3, I'm just going to go down to Tools and Copy Machine. And that's going to bring up our copy machine here. And it's just going to go through a few questions here. Are we creating a 3D or a 2D? Right now we're just doing a 2D. Here's the instructions that you also got with your probe, and you can click on there to learn more about it. The probe we're using is a normally closed. That's what comes from ShopBot. And then finally we have to pick the format of the file that we're going to use. And since we're going to be doing a 2D profile, what we would want for this is a polyline DXF file. And we go ahead and hit copy, and it brings in our scan resolution. Now this, you can hover over and it says should be greater than 0.1. This is the smaller the number here, the tighter and the better resolution that you're going to get. So the smaller the number, the better resolution you will get on this. So if I went down to 0.1, the safe maximum Y location, this is the starting position where it's going to start moving in the Y before it touches the part. And then finally the move speed, and right here the default value says 0.5. And these are something that your variables that you'll have to play with depending on what it is that you're trying to probe. When you hit finish, it's going to have you pick a name for the copy machine, and then the probe will start to ask you if it's ready to start the probe, and it will also give you one more option to would you like to use your keypad to move to another position. So you didn't have to do the zeroing of the X and the Y. Again, it's just personal preference. I'll show you at the end, but you would just go through these few steps here and go ahead and hit OK and be ready to start your probe. See, the probe moves in its first direction as positive Y, and every time it touches, it records that point, steps out to the scan resolution that you set in the software, and it will just continue itself around. So every time it hits there, you see the light turn on, and every time it's doing that, it's recording that point. You do need to be careful out here on corners, trying to get 90-degree corners with the probe. Sometimes will require you to go into your CAD software and do some node editing and manual cleanup. But as you see, it just keeps working itself all the way around this outside profile. And this is why I didn't go too deep with the tip when I set the 0, because I didn't want it to catch down inside those pockets. We'll come back and reset that and use those pockets in a few. Watch your cord too. Your cord, you don't want it to get bound up where it pulls out of connection or gets twisted up in itself. So you got to kind of stay with the probe and keep an eye on it. And here we are almost finishing our first profile all the way around. And as the probe comes, it knows where it started, and it comes back point after point after point, and when it gets to the point where it first started, it stops, and it's now saved you a DXF file on your wherever you saved that. So that was just called Guitar Probe 1. Notice I'm just using the keypad, moving into the next, this over here is this pocket. I'm just moving it down inside there. And I'm going to go and open up the SB3 software and just do the same thing again. I haven't changed any settings. I haven't went in and re-zeroed anything. All I did was use keypad, move it to the next portion that I want to probe, and then I'll now save this as Guitar Probe 2. And then when I go and import these all into the CAD software, they'll have them all in the positions lined up with each other. So I get done with the second portion, come over to the third. The X and Y is staying the same because I'm not re-zeroing it in between. The Z, it doesn't matter. We're just getting a straight line probe, a 2D probe. So the Z doesn't matter how far, if I get that perfectly back to 0 every time. But this is a really nice way to be able to pick up all these different holes and pockets and profiles and keep them all within the same location that they are. And then you see when I get done with this pocket, I know I have a deeper one here, but it's also using that same position. So I'll just move the probe off the edge a little, go down a little bit deeper, and just keep in mind the first move is always positive Y. So set it up so it's going to move in positive Y. And then just to save time in the video, I went around and did all the different parts. And sometimes you want to set your resolution real small to come in here to do these circles, and it's not always going to pick up a circle real well, and that's where we'll show you how to clean that up in the software. This will work in either VCarve Pro or Aspire, because all we've done right now is did a 2D scan of polylines, so we've just done point after point and created a DXF file. So I'll just start a new version here. 24 by 24, it'll fit on that blank. Material thickness is 1.25 inches. I got it 0 to the top only because I want to make sure that my pockets get to the right depth. And what I would do here is I would come up to import vectors from a file, and as you see here I've got 12 different DXFs. Every time that probe went around, I saved it as a separate DXF. So the first one that we saw was right here where it did the outline of the body, and again, it was just a personal preference thing. I made the 0, 0 point right here. The first moves in positive Y. It just so it's easier to trace. It doesn't bring it in somewhere out in no man's land. It's easy for me to find, but again, just a preference thing. So you can see it's brought in the guitar body. Obviously the things aren't perfect with a probe. I had a pretty hefty step over on that to run it through quick for the video. Didn't get my corners. I could have really dialed that down to a finer resolution. Would have taken longer and a lot less work for me here is cleanup. But you would just go through and import these in as you wanted to adjust them, and there they all are, all of them up there. So you can bring in all the vectors. Just so I don't have to go through bringing all 12 in, here's what it looks like when they all brought in. I brought in all different 12, and you can see the circles didn't quite come out perfect. Again, I had a pretty gnarly step over resolution on it, like 0.25, where I could have dialed that down to 0.1 and probed it. The probing would have taken a lot longer, but again, it would have given me better resolution. But for this example, what I did was do it fast, and then we can come in here. The first thing I would do is I would check the overall size of my guitar body, and then I would actually measure the physical one that you already had. And again, you got to take into account your probe thickness. You know, there's a 5 millimeter, 2 millimeter. There's different thickness of probes. So this is where you might have to come in and change your set size. And you can see a little bit more about that in the troubleshooting document that comes with the probe. But again, I would just measure mine. So, oh, my probe was this. I need to offset it just a little bit, and then you would just set the size that you need. And then this is where you're going to get really good at node editing and cleaning up your file. You come in here and find spots that you don't like. There's a little nip I didn't like in there. I can go into node editing and delete a couple of those points and try to get this back out. And again, I would reference one of the node editing tutorials to try to really get a grip on that, on node editing itself, because it would spend a lot of time where you come in here, smooth points, and just get rid of some of the stuff. Some of the stuff isn't even worth node editing. I would get measurements with a set of calipers, find out what they might need to be, and actually come in and just create new vectors. You can see here I spent some time because I wanted to cut this out, where I went through and did some node editing and some creating of new vectors, where I actually got some fine measurements with my calipers for my location holes, depths of the pockets, and sizing, and then just to show you the finished product, what we would do then is just take a look at, there's your different pockets, pickups, and all that was done with the probe. Yes, I did have some time in the software modifying some vectors to clean them up, but that would have taken me a lot longer by hand to have drawn. And there's just one purpose of the probe. Nothing, you know, hey, this is great, but you got to remember too, with a probe, you're replicating it in 2D or 3D, but depending on the resolution and the part size, is the probe really the best thing to do? Yes, for this it was fine for me. It's just a one-off that I'm doing. Sometimes you might want to consider even sending out to like a 3D laser scanner, where they can laser scan that and get the resolution on it perfect, where you wouldn't have needed to do the node editing. So you just think about, you know, what's in your budget, what is your time frame, stuff like that. So just things to think about outside of just using a touch probe. So here we're going to set up for the 3D probe. This is a climbing hold that I had on my climbing wall in the basement, and I broke a couple of them, and just hot gluing them back together. I don't trust putting my weight back on to climb them, so I've kind of got them together, taped down to my spoil board, and you can see I'm getting some measurements. When we set up for 3D, we need to know the size that we're going to probe. So I'm getting my X and my Y measurements, because I'm going to type this into the SB3 software, the material size to probe. And here's a trick, that bring your Z down. I use a thicker tape so it brings it up off the table a little bit, and then you're going to actually want to bring your Z down so it's about a 1/16 of an inch off the bottom. And then I like to do my Z axis 0 right there. And the reason for that is, if I zero my Z up above the surface just a little bit, I'm not going to be probing the actual ShopBot spoil board. If I didn't zero this right here, what the ShopBot would be doing is every single time it moves laterally back and forth, it's also going to be moving up and down, hitting that spoil board, which I don't need to record that. It'd be all stuff in the Spire that I'd have to go in and cut out anyways. So what I'm going to do with this is I save some time probing, as I set my 0 for my Z just a little bit up above the spoil board, and that's why I use a little bit thicker two-sided tape, so I can achieve this and still get the full probe of my part. And you'll see this again in the 3D model when we bring that in. So as we showed in the 2D. I just go to Tools, Copy Machine, but instead of this time doing a 2D outline, I'm going to do a 3D. Again, I'm still using my ShopBot Probe, and my format now is, you have a couple different options here, but for what we're going to go through in this example, I'm actually going to save this as a SBP file, which would be ready to cut on the ShopBot. However, with my probe, I don't always get the resolution that I want, and I'm going to be able to use the converter to bring it into a file that I can use in Aspire. So again, you can read more about why this is the option I'm picking back from your documentation that comes with the probe. But for this example, and this route of getting it cleaned up, I would do it as a ShopBot SBP file. And then when you go to fill in your display here, again, it's the size that we're going to do. Using my pencil marks on the desktop's spoil board, I know I had 6 1/4, 4 5/8, and then safe Z-axis clears. What this is going to be is how high the probe picks up between every single clearance. So I usually leave it with right what it says is the default 1. Sometimes you'll see people set this smaller just to save time. Again, the probe is a matter of just playing with and getting it the way you want. Maximum probing depth is where I keep this one at 0, because what we did back in the previous video was you saw that I zeroed that probe stylus just up above the spoil board, and you'll see when we start probing this in the next video that I'm not going to be going below 0 for probing, so it's going to save me from picking up all those points of it probing the spoil board. And then a step over value, again, depending on the resolution that you want. The tighter the resolution, smaller the number. And most of these here are all set at the defaults. The probe tip that you're going to use, push this in here. Finish, it's going to ask you that you'll need to pick a name, and then it's going to be ready to start. So going through those settings, again, you can look through the documentation that comes through there. If you hover over these, it tells you a lot of the defaults. So again, I made a temporary 0 of my X and Y right here at the corner of my line is. My Z, see how it is just above the spoil board. So as it moves along there, it's not recording those points. That's why I like to tell it to trick the Z a little bit up. And now here, as the probe hits the part, you see it slows down and starts doing its little steps where it records. But right now, if that would have been touching the spoil board, it would be picking up all those little points. It's a neat trick. Try it. You don't have to do it. It just saves you some time in the modeling. So here we are, it's just moving along, just showing you some different clips, had a few different parts that I had to do. And, you know, depending on the size of the part, the tip that you'll use, where you've mounted it on your spindle, and the resolution that you're trying to get. This one has actually need to leave some of it rough because it's better for gripping. And it's just going to work its way over. And let me tell you, this takes some time, okay? This guy right here took, 3 hours to probe with the resolution that I wanted. There's nothing fast or quick about this. It's unfortunately something you're going to see here every once in a while, where it's going to be a stuck probe. See how it's sitting here trying to reset itself? Something happened where the probe got caught up. It's trying to figure out a way to reset itself, but every once in a while you'll get a stuck probe like this, where it gets stuck in its position, and unfortunately at that time it's going to give you this horrible error message, and you pretty much lost that probe job. If you refer back to the documentation that came with the probe, it'll talk to you a little bit about how to recall what you've done so far, but usually, unfortunately, the best thing to do at this point is start it over. And these are, again, we're talking about a $400 probe, being able to do this versus a couple $1,000 laser scanner. It all depends on the job. This is just showing you an option and an accessory that we can add to your ShopBot. So I'll show you one more part here that I did. This is the last one that I needed to do, and you can see it just goes over. That pickup right there is that 1 inch that I had set. If you feel comfortable with your part and you know where it's going to be needing to drop and plunge all the way down in, you can set those different settings. But each time it hits, it's recording these points, and it's going to actually save this as a SB3 file. It'll be ready to go right back to the ShopBot. I even put a bolt in there to simulate the bolt that would be on there, just so it didn't go any deeper than it needed to be. And again, in the probe setup, I could have put on there how deep I wanted it to actually probe, so it wouldn't have gone all the way down in that hole. But something, get a couple small little tools or parts you got sitting around your shop and practice with it, and you'll get a feel for it. The next thing you're going to come do is get back in your ShopBot 3 control software. Again, underneath tools we have something called the Probe to Surface Translator. I click on this guy and bring it up, and what I'm doing is I'm opening a ShopBot Probe file. If we look back at my desktop, you can see my holds. Now here we have hold 1, 2, 3, and 4. So if I want to go ahead and convert these, I will just click on the ShopBot file. You want to use the Open a ShopBot Profile check, reduction factor, well we want to keep it the same size, and then you want to use Save DXF Surface. I want to actually save this out to a DXF that I can bring into my 3D modeling software. There's my hold 1. I've already saved that one. I'll just replace it, and again I do the same thing for 2 and save my DXFs, and again it's just naming them what they are. Save DXF hold 3, and go ahead, hold number 4. It's showing me a picture of the hold number 4, and then I go ahead and hit Save DXF and I bring that in. So now what I've created is 4 different files. It says done, that means it went through. I've created my 4 files and got them back to something I can bring into my Aspire software. So there's grayed out image, shows you what you scanned. Again, you want to just open your SB Probe file, save as a DXF surface, and then you'll be able to continue on with this example. So now that we have successfully converted this back, and this is just the step you have to go through to make the probing get back into a file format that's going to work in your 3D modeling software. So for this we need to use Aspire since we are going to manipulate the 3D model. So I just go ahead and create a new file. I just have a small block of wood here that's a little bit thicker than the model that I just imported. That's just from measurements that I got off the block I had sitting here in the shop. And now I go to the modeling tab, and then this is where you'd want to probably spend some time watching some of the Aspire tutorials on how to come in here and use these different parts that they have for doing 3D modeling. I'll bring in my hold 4. You can just see that the hold 4, it's pretty rough, the resolution that I had. You can kind of see down in here where the bolt hole was, and just kind of picking up the hex head from the but again, you'd go in here, learn a little bit more about your 3D modeling. It'd be a whole separate topic. But bring in your model, just to give you a quick overview how I would probably come in and tackle this guy. Usually go to model first before I forget, add my zero plane. It's nice to get rid of all this mess out here that we don't need. Unfortunately, with the way this thing probed, I can't just click on create a vector boundary, because what that does is put the vector boundary around, go around my edge. So what I would do is go back to the drawing tab, draw some sort of circle here, get good with your node editing, where you'd want to convert some of these different ones to arcs and move them around so they fit, and a lot of playing with this. And once you got this the way you wanted it, then you go back into the 3D portion. And again, this would be something I'd pick up an Aspire tutorial from the Vectric site versus sitting here watching me do this. Let's stick to the Pro. But then after that, I'd go into doing some sculpting and cleaning it up. And just to show you, after me spending 10 minutes in there cleaning the thing up, I went in there and you can see that I took and drew new vectors for the holes. If we look at the 3D view, you'll see that I've added my tool paths to it. And if we take a look at what this looks like after I've got it cleaned up, I'll go ahead and preview all these tool paths for you. Oops, I'm sorry. That's what happens when we're live. Things happen. But so there it is, cleaned up, and I just click on the rest to get rid of it. But I've left it a little rough because you want to simulate that rock that you're holding on to. I've actually went in with the vectors again and made the depth that I want with my pockets and the size diameter that I want to fit my bolts. But that would be a way of bringing in a 3D model that you scanned with the probe, spending a little time to clean it up, and then you've got your model that you're ready to toolpath and cut. I'll wrap things up just by going to our ShopBot webpage and showing you can read more and see the Digitizing Probe right there on our webpage. And basically what we've done in today's tutorial is we looked at a 2D file, how to go around and take the different points from the polylines, save them in different DXFs, bring them all in. You can do multiple probes in one file and have them come in proportion and location to where they are on the actual part. We also did a 3D climb hole today, which you can see in the picture of a shell. Is a very popular one people like to do, and the steps to get through probing that, coming in and using the translator, and then going back into your Aspire and doing a little bit of cleaning up. But the probe's a neat feature. Again, there's lots of different other 3D scanners and stuff out there, but you as the judge of what you need to do, think about, hey, am I replicating parts in 2D or 3D? Depending on the resolution that I need or the part that I need, the probe could be something that is very helpful for you and very affordable for what you need to do. But play around with it, and hope you enjoyed this training, and we'll see you in 2 weeks. Thanks.